All right, let's talk about artificial intelligence. Today, we're going to deconstruct it, cut through all the sci-fi hype, and get to the real core principles. We're going to figure out how you actually build a machine that can act intelligently.
So, where do you even start? Let's begin with the biggest question of all. How in the world do you teach a machine to be smart? It sounds like something out of a movie, right? But the answer, well, it starts by completely changing how we think about what smart even is. And that's our first big idea, really. To get a handle on AI, you've got to forget about building a robot brain, like in the movies. The actual goal is way more practical and honestly, way more powerful. So check out the textbook definition here. I want you to really notice the wording. Designing computational systems that perform tasks. See? It doesn't say a thing about consciousness or feelings or thinking like a person. The focus is 100% on capability, on what the system can actually do. And this is the absolute key takeaway. The whole point of AI engineering isn't to copy how humans think. It's to build things that can act intelligently out in the world. Any thinking or computing that happens, that's just a means to an end. And the end is always more effective action. Okay, so if it's all about acting, how does that actually happen? Well, believe it or not, almost all of modern AI is built on this one really simple, elegant idea: the intelligent agent. This is the blueprint for literally everything. So what is an agent? Just think of it as anything, literally anything that can sense what's going on around it and then do something about it. Its senses could be a camera, a mic, even just a simple thermostat sensor. And its actions, that could be anything from moving a robot arm to just turning on the heat. In this simple loop you see here, this is the heartbeat of every single agent. It's just a constant cycle. See the world, decide what to do, and then do it. That's it. From the dumbest thermostat to the smartest self-driving car, they all follow this exact same loop over and over again. And what's so powerful about this agent idea is how it scales. I mean, on one end of the spectrum, you've got your thermostat. Super simple, it senses one thing, the temperature, and follows one simple, hard-coded rule. But on the other end, you have something like a robotic surgeon. It's taking in tons of data, visuals, tissue resistance, and it's learned these incredibly complex strategies to do its job. But at their core, they're both agents, just operating at vastly different levels of complexity. Right, so how does an agent make that leap? How does it go from just following a simple rule to actually developing these complex, adaptive behaviors? Well, the magic word is learning. And one of the most powerful ways it learns is through something called deep reinforcement learning. And I'm not exaggerating when I say this. Deep reinforcement learning, or DRL for short, has completely changed the game. It has truly revolutionized how we get machines to learn from experience, kind of like how we do. So what's the big deal? Well, think about it this way. With classic programming, a human has to sit down and write out explicit instructions for every possible situation. If this happens, do that. But with reinforcement learning, we do something totally different. We just give the agent a goal, like a score in a game. Then we let it loose. It tries a bunch of stuff, gets points for doing good things, loses points for bad things, and over thousands, even millions of tries, it literally teaches itself the best way to win. It figures out its own strategy or policy. And this isn't some lab experiment, DRL is the powerhouse behind some incredible real-world tech. It's what's teaching drones how to fly through cluttered forests, what's teaching robot arms how to pick up and assemble things, and it's even helping to power the next generation of super advanced prosthetic limbs. Okay, letting an agent learn from millions of mistakes sounds great, until you realize you can't have a real-world robot smash into a wall a million times to learn not to. And that brings us to one of the single biggest hurdles in AI today, what they call the sim-to-real gap. So the obvious solution is to train them in a simulation, a virtual world. It's perfect. Inside the computer, it's safe, it's fast, you can run a million experiments, and a crash costs nothing. But the problem is, the real world is messy. It's unpredictable. There's friction, there's wind, there's stuff that just doesn't happen in your perfect, clean simulation. So right now, a massive amount of brainpower in the AI world is focused on this one thing, bridging that gap. The dream is to train an AI in a perfect digital playground and then have it be robust enough to work flawlessly and safely out here in our chaotic world. And that word, safely, is the perfect transition to our last and honestly most important part of this whole story. Because as these AI agents get smarter and more independent, we're staring down some serious ethical questions. I mean, just listen to this quote. It really hits you. We've never in history built a machine and given it the autonomous power to decide who lives and who dies. But that's exactly what's about to happen, not on some future battlefield, but in everyday traffic with self-driving cars. So if we're going to do this responsibly, we have to engineer for it. That means building systems that know when they're failing. It means creating rock-solid safety protocols for when things inevitably go wrong. And maybe most importantly, it means designing AI to work with humans, not just replace us, to make sure this powerful technology is always serving our best interests. Which leaves us with this final thought. At the end of the day, these intelligent agents are just tools. They're going to learn whatever goals we give them, and they're going to reflect the values we bake into them. So the biggest challenge ahead of us isn't just about the code. It's about all of us, together, deciding what values we want to teach them.